this limit has x approaches to infinity. Take a look at the function. We have 3x squared divided by x squared plus x minus 20. As you can see on the title, I said limits at infinity, horizontal asymptote. Then you might say, okay, that is easy. All we have to do is we graph the function and then we can see what the horizontal is. Yes, you're right. You can graph the function and see what the horizontal is. I gave you a graph. I construct this graph using decimal. Decimal is completely free. You can look it up on Google. You can use that on your computer or you can download the app. It is absolutely free. So all you have to do is to input the function and then they will do a graph for you. If you want to sketch the graph of the horizontal asymptote, you have to find out what it is and then you can say, so this one is y equals to 3 and then the first line you input the function, right? And then you can start on the next line and then you say y equals to 3 and they will graph that for you. And then regarding how to change the graph from a solid line to a dotted line or a dashed line, there is a gear icon. You have to click on it and then you can change the picture of the, not the picture, you can change the color of the curve and you can change that from a solid line to a dotted line or to a dashed line. I use dotted line for vertical asymptote and dashed line for horizontal asymptote to make everything super easy to read. All right. Now, yes, you graph this and then everything is clear, everything is obvious, and then everything is visible. But how about the math behind this? Now, in this video, I am going to dive into it. I'm going to give you a full discussion regarding how to find the horizontal asymptote using algebra. And then other than that, I will provide a full analysis regarding the two vertical asymptotes. So let's get started. So first of all, to find the vertical asymptote, it is not that hard, right? We discussed that in the previous section or previous lesson. So first of all, you have to factor the function first, top and bottom. Try to factor as much as you can. So the top there is nothing to factor. The bottom, the x squared plus x minus 20. I factor that to x plus 5 times x minus 4. And then nothing can be cancelled. And then immediately you can see that when x equals to negative 5 and x equals to 4, we have a 0 in the denominator, which makes the function undefined. So we have to say that x cannot be equal to 5. I'm going to change back to this because that will occupy a lot of space. So x cannot be equal to negative 5, and x also cannot be equal to positive 4, right? So when x equals to either of these value, we have a 0 in the denominator, and they cannot be cancelled using algebra, and then therefore we say that they are non-removable discontinuity. So they are non-removable discontinuity. I will just use DISC, continuity. And then what does that mean? That means they are vertical asymptote. I'll just write ASY for asymptote. So they are vertical asymptote. So without the picture, let's say you completely cover up the picture. So that means in your mind, you should have an XY axis and then one vertical asymptote at negative 5 and one vertical asymptote at positive 4. All right. Now, let's leave the vertical asymptote alone for now. How about the horizontal asymptote? So for the horizontal asymptote, whenever you find horizontal asymptote, you have to let x goes to positive infinity or x goes to negative infinity. So this one, let's follow x goes to positive infinity. So that means, what is that equal to? What is the limit equal to? So here is how you evaluate the limit. So let me write the function one more time. So I'm the limit one more time. So we have limit as x approaches to infinity, 3x squared divided by x squared plus x minus 20. Oh, speaking of the writing, do not just go ahead and then do the math like this. Every time you move on to the next step, just listen to me, please. Please do this on your paper. Every time you move on to a new step, you have to start with an equal and then you write the limit and then you do the algebra. Don't just jump right into the algebra because your instructor really hates this when you just completely ignore the limit. When you do scratch work on your scratch paper, fine, you can do anything you like. But when you provide a formal answer to your instructor, especially on a test, you have to write the equal and the limit. Okay, you cannot save time on this. You cannot save time. You have to write it. Okay, so limit as x approaches to infinity. So what do we have? We have 3x squared. All right, so I'm going to just do this. I'm going to show you the algebra right here so I can save some space to do the work. Okay, how do we do this? So this is so important. I'm going to do this in a different color. Let's pick a green. So what you have to do is you have to multiply this by a complex fraction. What is that complex fraction? The complex fraction is you have to divide each term by x raised to the highest degree or exponent in the denominator, which is 2. You can call this the leading degree, the biggest exponent or the biggest degree in the denominator. So that is, you have to divide each term by x squared and then 1 over x squared. So what that means is, so extend this to the next step. So x approaches to infinity, then you have 3x squared divided by, and then x squared divided by x squared plus x divided by x squared minus 20 divided by x squared, and then you simplify the degree or the exponent for me. Oh, the top, how come I didn't put anything on the top, huh? Okay, the top is 3x squared, just do a slash x squared. So the top, you have a 3 left, and then the bottom, what do we have? We have 1 plus 1 divided by x minus 20 divided by x squared, and then what happens as x approaches to infinity? 1 divided by infinity, 20 divided by infinity squared, they are all 0. That means when you reach to this step, all the fractions become 0. So at the end of the day, you have 3 over 1, which is just equals to 3. Or when I show my work, I like this. When I do my lecture, 1 plus 0 minus 0. So you have 3 over 1, which is 3. What does that mean? What does the 3 mean? The 3 means y equals to 3 is a horizontal asymptote. Y equals to 3 is a horizontal asymptote. Now, people ask me this, hey, do we have to divide the top and bottom by, do we have to follow the biggest degree in the denominator? Do we have to follow this? What happens if we follow the highest degree in the numerator? Now, here. So let me give you this. I'm going to do another example. So how about this? What if, just what if? So just what if? What if the top has a 3x to the 5th? Just a what if. And then the denominator has x squared and then plus x and then minus 20. No change in the denominator. What if the top has a 3x to the 5 and then you make a terrible mistake? That mistake is you are going to go ahead and then divide the top and bottom by, and then you follow the highest degree in the numerator. So that will be a 5. So let's change that to a 5. And then 5. This is a terrible mistake. I haven't seen this on my exams yet. I haven't seen this on students' exam yet. Please don't be the first person, all right? I haven't seen this yet. Don't be the first person making this mistake. So the top, you get a 3, no questions with that. The bottom is a problem. So this is 1 divided by x to the 3rd plus 1 divided by x to the 4th minus 20 divided by x to the 5th. The math is right, but what happens when x approaches to infinity or negative infinity? I don't really care. Look, you have a bunch of 0 in the denominator. So you have 3 divided by 0 plus 0 minus 0. And then 3 divided by 0. Problem. So that's why you have to divide, write this down on your notes. You have to divide the top and bottom by x raised to the biggest exponent in the denominator. All right, one more time. You have to divide each term by x raised to the highest degree in the denominator. So you follow the denominator. Okay, denominator, because we cannot have a 0 in the denominator. So that's why everything depends on the highest degree in the denominator. So now x equals to 3 is done. So in your mind, so now you build on top of that picture. So you have x equals to 4 and -5, and now you have a y equals to 3 as the horizontal asymptote. Okay, so let's provide a deeper analysis for each of the vertical asymptotes. So the first one I have is x equals to -5, right? How do I know on the left side it goes up, on the right hand side it goes down? So let me tell you why. So here is why. So we have x approaches to -5, right? I will just do it like this because that makes everything so easy to see. So -5, this is left, and then this is right, right? And then on the right, you have a -4, -3, and then you are approaching to the positive side, and then this side is a -6. Now, so as x approaches to -5 from the left, then you are picking a number that is so close to -5 from the left. So this one, I will just hit this. So I will just pick the top, so that will be 3, and then -5 squared. How do I get this? This is the given function, 3x squared, right? You just plug in a -5. And then the bottom, do you see that in the factor form, there is x plus 5 and then x minus 4. So here is the thing, you have to work with the x plus 5. All right, so x plus 5, I will pick something that is so close, like this, -5.0001. This is so close to -5 from the left, and then you add 5 to it, add 5 to it, and then the 4, the -5 doesn't affect those two terms, then I will just put a -5. This is a technique that you have to use. Now, what do you see here? Do you see that when you have a -5.0001 plus 5, so this term gives you negative and very small? Am I right? That is a negative and very small. When you take that times the -9, overall, the denominator, times a negative very small times a -9. So overall, the denominator gives you a negative and a very small number, right? Very small number or quantity. And then you take the top, which is a positive. So you are taking a positive value, whatever that is, I don't really care. You are taking a positive value divided by negative, and then very small. What do you get? Oh, negative times negative, positive. Positive, very small. Positive number. So let's say 10 divided by 0.00, a bunch of 0 and then a 1 or a 9. What do you get? At the end of the day, when you take a number divided by something extremely small, just try this. 5 divided by 0 point a bunch of 0, 1. You will get something that is close to positive infinity. Okay, so as a result, as x approaches to -5 from the left, the curve goes up. Do you see that? Look at the graph. The curve goes up, right? And then what happened when x approaches to -5 from the right? So that doesn't affect the top. The top, I will just use a -5 square. And then from the right hand side, I will just pick a -4.9999 plus 5. And then -5 minus 4. Okay, so this will be a positive, right? So this is a positive, very small. This is times a -9. What do you get? Then you will get something that is negative and very small. So you have a positive divided by negative, very small. What do you get? You get a negative infinity. Just picture this. 5 divided by this versus 5 divided by any number. This is something that you have to study in limits. So that gives you a positive infinity, that gives you a negative infinity. So that's why as x approaches to -5 from the right, the curve goes down. Do you see that? The curve goes down. The parabola, the upside down parabola. And then how about the other one? The other one is 4, right? It's x equals to 4. So I'm going to use green. So the other one is a 4. So I'm going to draw this for you. 4. On the left hand side we have a 3. On the right hand side we have a 5. And then this is left. And then this is right. So we are picking a number in here and there. So this x approaches to 4 from the left. And then this is a 3 times 4 square, right? And then this time, this will be a 4 plus 5. And then what affects the 4 is the x minus 4. So I will be picking a 3.9999 minus 4. So this one is negative and then very small, right? And then this is a positive. Overall, you have a negative and then very small in the denominator. The top is positive. Positive divided by negative, very small. What do we have? We have a negative infinity. So as x approaches to negative 4 from the left, the curve goes down. And then x approaches to 4 from the right. So this is 3 times 4 square divided by 4 plus 5. And then 4.0001 minus 4. Okay, so this is a positive and then this is a positive and then very small, right? Positive and very small. So overall, we have a positive and then very small. So the top is 3 times 16. I don't care what that equals to. And then divided by positive and then very small. What do you get? So you get a positive infinity. So that's why as x approaches to 4 from the right, the curve goes up. Let's use the graph to make sure I am right. Do you see that? X approaches to 4. On the left goes down, on the right goes up. Now, there is one more thing that I would like to discuss. Do you see that on the graph, on the right hand side below y equals to 3, do you see that the curve actually touches the horizontal asymptote, right? The point is 20, 3. Do you see that? So how come there is an intersection at 20, 3? Because if you're thinking about horizontal asymptote, the curve should be getting closer and closer to the horizontal asymptote without crossing or touching the horizontal asymptote. But how come there is a intersection? Why? So here is why. Because sometimes the curve can look like this. Sometimes you might see a curve that looks like this. The curve will just go up and down, but it is getting closer and closer to a certain number. This type of function exists, and then eventually it will just go like that. This is a possible answer. So although the curve goes up and down, and then that causes the horizontal asymptote many times. So let's say y equals to 0. The curve goes up and down, that causes the horizontal asymptote a million times. But when you look at the horizontal asymptote, you have to look at all the way to the right. X approaches to infinity. All the way to the right or all the way to the left. It's the right end or the left end behavior. I don't care how many times the curve causes the horizontal asymptote. You have to look at the end. The left end behavior. So as long as the curve approaches to the curve approaches to the horizontal asymptote, then that is still a horizontal asymptote, like up and down, and then all of a sudden, it just goes up, so closer to that horizontal asymptote. So this case exists. So that's why I create this example. So although there is an intersection, don't worry, you are not wrong, because you have to look all the way to the right side or all the way to the left side if you are talking about horizontal asymptote. The biggest conclusion that we have to make is the horizontal asymptote describes the right end or left end behavior. Okay, right end and left end behavior. So that's all for this video. If you like it, give me a thumbs up, and I will see you all in the next example. Signing out.